G'day my fellow mates. If you spend enough time online, eventually you'll find someone trying to make their own Roblox. And usually, the project starts something like this. Okay, first I need a 3D engine. But there's a problem. Roblox isn't just a 3D engine. If all we build is a renderer, a physics engine, and a scripting language, we've basically made a small version of Unity, or Godot. Roblox is something much larger. It's a game engine, multiplayer platform, social platform, hosting service, development environment, asset marketplace, account system, and game launcher all working together. So before we write a single line of code, we need to answer a much more important question. What are we actually building? Let's imagine we already finished an amazing 3D engine. It can render millions of triangles. It has lighting, physics works. You can move a camera around? Great. Can someone make an account? No. Can they upload a game? No. Can two players join the same server? No. Can someone click a button on a website and launch that game? No. Can developers write scripts? No. Can players customize an avatar? Also no. That's why calling Roblox a game engine doesn't really describe the entire product. The engine is only one layer of the platform, so let's break the platform into its major pieces.
First, we need the application the player actually runs. We'll call this the game client. This is responsible for things like creating the game window, receiving keyboard and mouse input, rendering the world, displaying UI, loading assets, communicating with the server, and representing the player's local game state. Eventually, this is the program that opens when someone presses play on our website. Think of it as our equivalent of the Roblox player. But multiplayer games can't trust every player's computer. If the client were completely authoritative, someone could modify their copy of the game and say, "Actually, I have 1 billion health," or "Actually, I just teleported across the map." So we also need a game server. The server will maintain the authoritative version of the multiplayer world. It can handle things like connected players, authoritative game state, replication, remote events, server-side scripts, physics, decisions. Inside the client, we need the actual graphics engine. This takes our world, objects, meshes, materials, lights, cameras, and turns them into pixels. We'll eventually build systems for GPU initialization, render pipelines, meshes, materials, textures, cameras, lighting, instancing, and scene rendering, but we are going to start much smaller. Our first milestone won't be a giant Roblox world. It'll be a triangle, because every giant game engine has to start somewhere. Roblox games aren't just 3D worlds. They have inventories, health bars, menus, chat, buttons, leaderboards, developer-created interfaces. So our client also needs a UI system. Initially, we'll use it for our own engine interface. Later, we'll need to decide how game developers can create UI inside their games. That introduces an important distinction we'll see throughout this project. Engine UI versus game UI. The tools we use internally don't necessarily have to be the same. Systems. Next is input, keyboard, mouse, gamepad, potentially touch later. At first, input sounds easy. You press W, the character moves forward, done. Except eventually we have UI consuming input, the game consuming input, the camera consuming input, scripts listening for input events, and potentially different input devices all controlling the same actions. So instead of scattering keyboard checks throughout the engine, we are going to build a proper input system. Then things become interesting. If our server contains the authoritative world, the client needs some way of knowing what's happening inside it. When another player moves, our machine needs to receive that information. When we fire a weapon, our machine may need to tell the server. When a new object appears, the server may need to replicate it to every connected client. That means we'll need a networking layer. This will probably be one of the biggest systems in the entire series. Now we leave the engine entirely. Players need identities. So we'll eventually build an account system. That means things like registration, authentication, sessions, profiles, owned games, avatars, and potentially permissions. The game client will need to know which player launched it. The website will need to know which account is logged in. And our backend services will need some way of verifying that identity. If creators make multiplayer games, those games need somewhere to run. So eventually, we need game hosting. At the simplest level, we could manually run a server executable, but a real platform needs to be able to say, a player wants to join this game. Find or start a server for them. That leads into concepts like server instances, matchmaking, server allocation, game versions, player limits, deployment, and eventually scaling. We aren't building a worldwide data center network for now. Then there's an easily overlooked piece of Roblox, the launcher. Imagine you're browsing our website and find a game. You press play. A website cannot simply become a native 3D game client. Something needs to bridge those two worlds. So we are eventually going to build a desktop launcher. And that means we also need a website. The website becomes the front door to the entire platform. Eventually it can contain accounts, profiles, game pages, game discovery, thumbnails, descriptions, creator profiles, avatar customization, and the play button that launches everything else. Notice how far we've already moved away from simply making a renderer. This is now a distributed software platform. But somebody has to make the games. That's where our equivalent of Roblox Studio comes in. Eventually, we'll build a separate creator application where developers can create worlds, insert objects, modify properties, import assets, write scripts, test their game, and publish it. This will be part of the expanded portion of the series because building a good editor is practically an entire project by itself. For now, we'll focus on making the underlying engine architecture capable. Then, of course, there's physics. Objects need to fall, characters need to stand on the ground, parts need to collide, forces need to move things. Eventually we'll explore rigid bodies, collision detection, collision response, constraints, gravity, and simulation stepping. Physics will be part of the expanded edition because it deserves its own deep dive. And finally, one of the systems most closely associated with Roblox, avatars. A player's account needs some representation inside the game. Eventually, that introduces character models, skeletons, animation, clothing, accessories, customization, ownership, and replication. The avatar system will connect the website, account system, asset system, renderer, physics engine, and networking layer, which is a perfect example of why we need to think about architecture before writing code. Because without some kind of map, projects like this become spaghetti extremely quickly. It's easy to write. Window receives keyboard event, camera moves, but later you discover the UI also needs that event. Then scripts need it. Then the game needs it. Then suddenly your window code knows about the camera, the player, the UI, the scripting runtime, and half the engine. So throughout this series, we are going to keep asking, which system should actually own this responsibility? So that's what we are actually building. Not just a game, not just a renderer, and not really just a game engine. We are building a small-scale online game creation platform composed of multiple programs and services that eventually work together. And we are going to build it from the bottom up. In the next video, we'll create the project itself, decide how we are going to organize the codebase, set up our dependencies, and get the absolute minimum application running. Then we'll start working.